Hi, myself Polish. Today I'm going to solve it. The machine learning week 4. Assignment 3 solutions. Assignment 3 solutions. Okay, so I think you will get the folder of like this week 3 solutions. I will go with the solutions of MATLAB environment, MATLAB offline, but I will submit the offline MATLAB to the online. So let's see. And this is the course, and in the week 4. This is the assignment. We watch the assignment is the last. So let's go to the MATLAB and see. I will recommend it you before starts the MATLAB. You will very well study and get clarifications about the theoretical knowledge as well as the PDF. They will give into for instructions to solve how to solve the problems. So it is the one versus one classification problem part 1 of one versus alls, and it is the main file. Exercise 3 is the main file. So in the main file we are starting from here. It is the command for clear and clean all the variables from the previous, and it is the set of parameters that input parameter of layer of size 400 and number of layer levels is 10th level we are using here. Now goes to the this part. Here in this main part you will not modify anything. Remember, in the main program, this is the main part, you will not modify anything, only you will modify in the functions. So it is the visualization of the data. Here we are giving the statement that we want to visualize the data. After that, come back to 3 and come back to the next. It is the part where we are imported our input files. After importing the input files, we're showing that the input file x have 5000 into 400 and y is the 5000 into 100 set of data. From here I am measuring the size of the input with, and it is stored in n. So it is the random indices, takes the random indices from the input values of f, and now cell is taking the 100 random indices values from random indices. Now if you go further, then here we are displaying the cell mean 100 random values we are displaying here. So how we will display, I will show you and when we will run the programs. Now come to the next sections of vectorized logistic regression. You know logistic regression is there, so we want to modify with the vectorizations method of logistic regressions, and in logistic regressions we are adding one more term, so that is lambda by 2 end from the I is equal to 1 to summation over I is equal to 1 to end and theta to the theta L subscript of the ij its square. Okay, so this time we will using here. So we are giving the text stating that Euler cost function with regularizations, and we will calculate the cost function and in the gradient here. Now they given the theta's values already. This theta's values is provided, the -2 -1 1 and 2, and x of t is the another values. It is actually being taken to the values of 1 of 5 to 1, and it is reshape. The reshape is what it is converting from vector dimensions to the matrix representations. We are using reshape. Now come to the part is the outputs. In the output is this 1 minus, sorry, 1 0 1 0 and to 1. All the values is taken. If it is taken from 0.5, then it will proceed, and it will proceed it will take and it will proceed, and you're taking the lambda's values. First is initially 3. So this function is very careful about that. The g and gradient, g is the cost functions, and gradient, that once the gradient is the gradient functions, gradient is in the gradient, it will returns, and we are calculating this in Euler cost functions, and Euler cost functions there, and we are using the argument theta, input, output, and the lambda values. So let's go to the Euler cost function, how it is worked. So Euler cost function is here. In the Euler cost function, this thing will be given. We should have to return the j values and the gradient value, cost function value and the gradient value we should have to return. So all the hints is given here. Now see what is it working is j theta, sorry, h theta. I mean, whatever the we are writing h theta of x in actually in theory, it is the h theta. H theta is the values of sigmoid. Sigmoid is a function which is calculating x into theta. So it is the net input value. In the input values here we are using an activation function. You know, sigmoid is the activation function of sinusoidal activation function. So it is sigmoid. Let's go to the sigmoid function and let's see how it is working. It is the sigmoid activation functions. The activation function, the equation is given by 1 divided by 1 plus exponential, I mean e to the power minus z. Here you can write z as a theta transpose of x, as sir told in the video session. So come to here again. Now it is taking the j value. J is the cost values. Cost value is 1 by m to minus 1 into theta transpose log. You know these equations, but it is the new. Okay, it is the cost functions, and the new is something added. It is like this. It is the regularized cost functions. When you have added these terms, it is the regularized cost functions. Beware about that and write the values very properly. Now we are taking the temp value as a theta value and temp 1 as a, where temp 1 values are taken as a 0, because the first values is the bias values, and the bias values we will consider as 0 now. And we will calculate the gradient here also. How we will calculate the gradient? Gradient is equal to 1 by m into x transpose h theta minus 1 and lambda by n into temp, which is the gradient values we consider here. That will give, return the gradient, and grad is equal to gradient. So for all the rows and column it will return. It is the functions of Euler cost functions. Now let's go to the main function. So up to here this functions conclusions is done. Now what happened, it is given that calculated cost function given in the j here, and expected cost function they told and calculated previously, and they were told that expected cost function will come as 2.534819, and the calculated gradient will give the values of the gradient in here, and expected gradient they already calculated, and the gradient will give the values as like this. So the program is pause for now, and if you press enter then it will be proceed. Now one versus all testing. In the one versus all testings, uh, we are now going to the showing that training one versus all logistic regression. So we are considering the value of lambda as 0.1 and all theta. All theta means the values of the theta, as told that the values of the theta be, instead of initiated as 0, you can initiate it with any number. So actually all theta will give the return values of theta, and how it will be returned, it is calculating in here one versus all in these functions, and with the taking the argument of x, y, number of levels and lambda. So let's see one versus all how it is returning the values of theta. One versus all is here. So in the on versus all, see, it is will be predefined. We will go through that, and let's come down. Yeah, initial theta is the 0 n plus 1 plus 1s. Instead of taking as 0, we are taking with some values, and the options. This thing is quite critical, so I will refer you to go to the video and take the sessions again and understand this better way, because we are using very shortcut method here. Gradient object functions we are using, and gradient object we are making on, and maximum iterations we are taking the consideration values of 50. Now it will be inside a loop, it will be run up to number of levels. How many levels we are taking? We are considering for 10. So it will be upgraded up to 10 times as it is in loop, for loop. So all the theta, it will gives the returning values of here when f min fi in cg, with the taking of the argument t as linear cost functions, with the take the argument x t y is equal to is equal to assignment of c and lambda and initial theta and options. This part is a little bit critical. So let's see all the codes here. So you will write the code and execute that once. It will work correctly. I'm sure, pretty much sure. Now come back to the main code and program is paused here. Now if we go to the next part, predict one versus all, how it's worked. Predict is equal to predict one versus all. It is another function, so where we are predicting to the all theta's values and the x number of integers values. So how it is work, predict one versus all, it is given in the function. Let's go to the function and let's see. Predict one versus all. Predict one versus all is defined for area, your number of level. It is predefined, you don't need to modify here. Just you will go to the down and actually you will write the code here that predict, that is the sigmoid functions, and it will to return the value x into all theta transpose. Okay, why it is theta transpose? To match the matrix dimensions. Here I'm using the theta transpose. Okay, all theta transpose, and it will return the values in a matrix forms here, and it will take the maximum values. I already written over here the discussions. Okay, so predict one versus all will return all the predicted values of the theta, and it will return. Now go to the main function. After main function, here it is complete. So um, it is the main function is complete. So let's save it and run it. So we press another key, I think. Yeah, it is now running. So it is loading the visualizations of the data. First 100 data, how it is plotting. First time I told in the main functions, it's a plotting graph of visualizations data. Now press enter, it will goes to the your calculated cost function is that one, and expected cost function is that one, and calculated gradient is your that one, and expected gradient is that one. I mean it is completely matched, so your program is fine. So let's proceed with press enter. So it is calculating the training one versus all gradients for iterations of 1 to 50, and every 10 times, because we are making the loop of 10, so up to 10 times it will proceed the values and the cost will be optimized. Let me complete the iterations. To better understand and more classifications clarify, I will suggest you please to go to the video lectures and take a note of each and every video lecture. It will make you better understand. So okay, all right. So program is paused now. So press enter and let's see the accuracy of the results. So training accuracy in my numeric data sets is 95% till now. It is over. The main programs is over. Your task is completed here. So now submit it. Okay, submit it. So it will send your assignment graded to their server. So I want to use my last token values, so I want to press here y only, so it will proceed. After checking, they will evaluate my grade. Yeah, that is nice work. As the mandatory tasks of all the thing is proceed, so it is nice work. Fine. So let's go back to the main programs. It is the main functions. Okay. um, display data. Display data that for initialized, you will just mm, you will just display data, you don't need to modify here. Okay, all the things they will give. Now if min see how it works, they will give these things code, no need to modify here also. Be sure it is working perfectly. Euler cost functions, last part we will do only that part in your coding. You need to write the code here on only this part, and let's see the complete equation of that one. Okay, fine. So 1 versus all, let's see the 1 versus all. It is the last part. You should have to calculate the 1 versus all only. That's part of 2. Yeah, this will give in, and that one also given. Okay, that one also given, so don't worry about that. Your code will be here up to here. It will be your code. Okay, so good. And predict, how it is work. Predict is actually the predictions, the all a1, a2 and a3's values, how it is works. It is that, and it is the near signal values in the layer 1, and in the layer 1 we are using the activated the signal with sigmoid functions, and we will storing as a a2. And what happened, it is the activated signals, sorry, net signals in the a2, in the layer 2, and a3 is the sigmoid function. We are activated the signal, sorry, net signal using the sigmoid function here. So to here complete and predict 1 versus all, you will write on, you need to write only these codes to predict 1 versus all to get all the predicted theta's values. Okay, and sigmoid function you already know that sigmoid function is very little small functions, and submit it, they will send the grade at their server. So after here it is complete. So my main program is done. So in addition with that, if you want to check the digit, then you can run that programs. So in that program you only need to modify some of the code is here. Wow, it is work. Let's see, already I discussed that thing, so I'll not discuss. So come to the part later. Acha, randomly selected 100 data, already I discussed this thing also, and display data already discussed this thing. Now loading the parameters, and to show the result is parameters and loading. Okay, ex3 weight.mat, actually what happened here, we are imported the weight values, okay, that they're giving already in the file ex3 weight.mat in that format, and implementations is here. We can check it. Now we will check it one by one digit. So the code is main code to check it one by one. The main code is here. Okay, so let's run the programs, and first what happened, just cut it and clear all the values and variable. Okay, now as supplementary or as extra you can run it. So I already save it. I want to run it, so this is running now. Yeah, fine. The program visualization data is over. It is showing the visualization data. Now fine, program is paused. You want to continue, let's continue. Let's see. Training accuracy 97% is told, and program is paused. If you want to check digit by digit, then press enter.